Use the graph paper to find the coordinates of the point of intersection of the curve y equals x squared and the line x plus y equals 8 in the first quadrant. Okay, so we need to graph these. So y equals x squared then. Here, let's draw the coordinates for that. Let's just choose some coordinates that are convenient. And here, if we move the x over, it will be y equals, and it will be 8 minus x, won't it? And let's draw that one as well. Okay, so let's put the x values here, and the x values here. And let's have a look at what coordinates we want to plot then. We're going from 1 to 4. So if we do 1, 2, 3, 4 then, and 0 for all the coordinates for the curve, 0, 1, 2, 3, 4. Y equals x squared then, square the 0 to get 0 squared is 0, 1 squared, 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, and here, if we do 0, 1, 2, 3, 4 again, 8 minus 0 is 8, 8 minus 1 is 7, 8 minus 2 is 6, 8 minus 3, 5, and 8 minus 4 is 4. So that's a straight line anyway, so we don't need to really mark all those points off. So let's move these down now, while we sketch the plot. We'll just move them down, say to here, so that we can see what we've got, and then we'll move them back up in a moment. So let's do the plot then. So we've got, I'm just going to put these values here above. So this is 1, this is 2, this is 3, and this is 4. So hopefully we can see everything now. Yep, so these are the 0, 1, 2, 3, 4 values. So at 0 it was 0. So I'm just going to mark that one in at the very bottom here. And this is the y equals x squared. Then at 1 it was 1. Now there's 4. So we're going up in 4. So this is 2. So it'll be half of this. It would be here, wouldn't it? Halfway up one block. Okay, that's that. And then at 2 it was 4, wasn't it? So we can mark off that. And 3 it was 9. Now there's 10 and there's 8. So halfway between will be 9. 4 will be 16, which will be here. So I'm going to try and draw this now. I'm going to draw it with a dashed line because I've got a digital pen and it's not easy to draw with a digital pen. So it's easier for me on this arrangement to draw it with a dashed line. Okay, so that's y equals x squared, and then y equals 8 minus x. 0 it's 8, so we can mark off that point there. Let's just choose the middle one. 2 it's 6, so 8, 6 is here, isn't it? And then at 4 it's 4. 4 it's 4. So that should form a straight line. So let's draw that straight line then. Come through here. Yeah, all these points are fine. So we've got our straight line there. Okay, so let's label the graph. This is y equals x squared. And this was the line, what x plus y equals 8, wasn't it, originally? Or y equals 8 minus x. So let's have a look at the question then. Use the graph paper to find the coordinates of the point of intersection of the curve and the line in the first quadrant. So let's mark off our point of intersection, which looks like it's here. So I'm going to mark off that. Let's try and mark it then. It's going to be about here, isn't it? I think. Somewhere like that. And also across here. Somewhere like that, it looks like to me. So let's mark off the points then. This point here, what is it then? We've got 2, and this is 2.5, so this is 2.1, 2.2, 2.3, 2.4. And this value here is, this is 4, this is 6. So this is 5. There's 5 there. So each square is 0.5, isn't it? So 5.5 looks like it's... Oh, hang on. Let me just get rid of that so we can see it a bit more clearly. How many squares? 1, 2, 3, 4, 5. So 1 unit is 5 squares. 2 units is 5 squares. So we're going up in 0.4s. So it's back 1 0.4 from 6. So that's 5.6, isn't it, if we go back 0.4? Yeah, 5.6. Okay, so each little square was 0.4 there, and we got to 5.6. So let's have a look then at the question. Use graph paper to find the coordinates of the point of intersection of the curve. So answer, x was equal to, and y was equal to. Let's have a look then. 2.4 and 5.6. 5.6 from the curve from inspection. So part B now. State whether or not it is possible to find a point of intersection of the following straight lines. Show how you have made your decision and give a reason for your answer. So here we've got y equals 3x plus 4. Gradient 3, intercept 4. This one here, if we move the 3y over, so I'm moving that over straight away to be with the 13, and I'm reading it from right to left, equals 9x. So I hope you can see that. What we did there was move the 3y over. 3y plus 13 is equal to 9x, and we can write that down straight away. So 3y is equal to 9x. Move the 13 over to minus 13. Then move the 3 from times to divide on the other side. So 9 over 3 is 3x, minus, and then 13 over 3, isn't it, when you divide 3 on the whole side. So there's our two lines. These lines both have gradient 3. Both have gradient 3, and as such are parallel. Consequently, they do not intersect. They've got different intercepts values as well, of course, so they're not the identical line. So they don't intersect because they're parallel.